Today we'll be discussing how to show different types of changing motion in a position versus time graph and a distance versus time graph. So at Moberly we have basically two setups for our graphs. Now for our position versus time graph, it's usually going to be a single quadrant, so it's going to be your positive quadrant that we're familiar with. So if you look at this right here, it's a positive quadrant, and that's going to let us know that's going to be our distance versus time quadrant. So in your other classes, one of the other sections, they may show it as an x versus time. In my classes, I use a distance versus time, so we don't get confused, because this is really the y-axis, and some kids are like, well, why is the x there? Well, x stands for position. So in traditional physics, x stands for position, and that's why. But in the distance versus time graph here, you know that the distance is going to be on the y-axis, and it's going to be in units meters, while the time is going to be on the x-axis, and that's going to be in units seconds. So when you create these graphs, you're going to have to label them properly. Other things that you need to be aware of is that this x-axis right here, the time axis, is it's just the x-axis right here measures time, and the y-axis here measures distance. And so as you're going over here, the 0 point, that's 0, 0. Now the 0, at this point, you're looking at 0 meters. And anytime you move away, you're going to have a positive direction, because you're moving away from your starting point. And it confuses some freshmen. Yes, I know this measures time, and you're looking, it says time, but it's actually measuring distance. It's kind of like on a map where your lines of longitude, they go up and down, but they measure east and west, and your lines of latitude, they go side to side, but they measure north and south. So this one goes side to side, but it's really measuring over here. Every one of these is measuring how high it is, how high that is. And what's the lowest possible point? Well, 0, 0. So every time I'm going away from that point, every time I'm getting farther from 0, that's a positive direction. On the reverse, if I go back down, so I'm going back down here, I'm going back to my 0 line, that means I'm going in a negative direction. So whenever we have a question asking about, describe this kind of changing motion that we have, there's always two things that we're looking for, because we're dealing with velocity, and velocity is a vector, and it consists of two concepts. The two concepts that make up velocity are going to be direction and magnitude. And as you can see in the writing that I have here, that we're going to be looking at for this specific graph, a positive increasing. This is going to be the direction, the positive. This is going to be the magnitude. Is it getting bigger or smaller? So, or my speed. So let's go ahead and create this one. And what we're going to do first is recognize, what is the direction going to be? Am I going to go up or down, or am I going to go up, or am I going to go down? Well, this says positive, so as we notice that I'm going to be getting away from my 0 line. And the next one says increasing in speed. So that means I'm going to starting off slow, and end up fast in a positive direction. So what I recommend you do is create a slow line. And what's the slowest possible line on a distance versus time graph? Well, that's a speed of 0. Slow, and then show a sharp angle at the end over time. And then just connect those. That's not a very good connection, but there it is. So if you ever see it curve up from left to right, that's going to be a positive increasing. Now let's go to the velocity versus time that we have over here. Now, this is velocity in meters per second, and this is time in seconds. So when I draw a line here, I'm going to have velocity over my time. Well, what does that equal to? Well, this equals acceleration. So this line represents acceleration, while the velocity over time on my distance versus time graph, so it's going to be distance over time, that's going to equal velocity. So this line here measures velocity, while this line over here measures acceleration. And so therefore the lines cannot mean the same thing, even though they look on similar graphs. So a diagonal line here does not mean a diagonal line on your velocity versus time graph. So let's go transfer this idea to this next graph over here. So just like before, let's look at it as direction first and then increasing. So to get this down, you need to understand that there's two quadrants here, the positive quadrant and the negative quadrant. On the distance versus time graph, the direction of the line indicated if it was going positive or negative. Here, on the velocity versus time graph, it's the quadrant that indicates whether you're going positive or negative. So, am I positive? Yes. That means I will only be using the top quadrant. I will not be using the negative quadrant. And you need to use that testing strategy on the quizzes and stuff to help you out with that. So on a quiz or whatever, if you have 4 options and the question asks you for the positive increasing, just go ahead on a velocity versus time graph options, get rid of anything that is in the negative quadrant, and that'll cancel out 2 of your 4 options. That's an easy testing strategy that I've stressed to my class. So we know that we're going to be using this quadrant here. Now it's going to be increasing. What does increasing mean? It means increasing speed. Remember, this line, this midline, is 0 meters per second. That's slow. So you're going away from slow. You're starting from slow at time and going away from that. That means you're going to be starting at 0 meters per second, and then you're going to be going away from that. That doesn't mean this, the diagonal line going up does not mean the same thing all the time. And I'll show you when we get to our negative slowing down. So let's go, again, positive increasing on the distance versus time graph is going to be going up away from 0, starting off flat, ending angled, and connecting that. And positive increasing on the velocity versus time graph is going to be your top quadrant, starting from the 0 speed and going away from the 0 speed into the diagonal line. Let's go to the next one. Positive decreasing. Now, when we say decreasing, we mean decreasing in speed. So, am I going to be going up or down? Well, I know that it's positive, so I'm going to be going away from my 0 meters. So I'm going to be going in this direction somehow. And decreasing means I start off fast, but I end up slow. So how does fast mean on a distance versus time graph? Well, I have a sharp angle. So I start off sharp, and then I end flat. That flat means 0 meters per second, and that sharp means some meters per second. Do I know which that is? Not necessarily. So there I am. Compare the one that we had previous. You had basically a concave bubble curve here, and here you have a convex bubble over here, or cave line. Now let's take this and transfer this to the velocity versus time graph. So which quadrant, direction first, which quadrant am I going to be in? I'm going to be in the positive quadrant because it's a positive direction. And am I going to be going from fast? I'm going from fast to slow. So I'm going from fast to slow. Well, what does slow mean? Slow is 0 meters per second. So that means I'll be traveling towards the midline. That means I originally at time 0 starting away faster than 0. That's some speed faster than 0, and I travel to 0. Now compare those two speeds here. Let's go to the negative decreasing. Now what does negative decreasing mean? Negative decreasing, negative increasing just means my line is going to be going down on a distance versus time graph. So I know I'm going to be going down left to right some way. Now it's increasing speed. Again, so what does that mean? It means that you start off slow, then you end up fast. So what does slow look like? Well, slow is a flat line, and fast is an angled line. And you're not going to be going this way on that angled line just because it's going in the opposite direction. So angled, and then you connect the lines. I know it's not perfect, but these are qualitative graphs. So now looking at the velocity versus time graph, what kind of direction am I going to, positive or negative? Well, it's negative, so it means it will be in this quadrant. And it means I'm increasing speed. And just like before, this is 0 meters per second, so I'm going away from my slow speed. So I'm starting from my slow and going away. And then finally, negative in decreasing, again, I'm going down left to right some way, because it's negative direction on the distance versus time graph. I start off angled, I start off fast, and then I end flat. So the graph is going to look like that. And then as far as the velocity versus time graph, it's a negative direction, which means I'll be in the bottom quadrant, and it's decreasing. That means decreasing speed always means going towards my midline. So that means I start off somewhere over here, and I go towards the midline. Now look at the decreasing speed here, and then look at our original one. Both of them were going upwards from left to right. They do not mean the same thing. So don't get those two things confused. If you need any help, ask a teacher. Hopefully we can get this, you can get this figured out.